Okay, so what does your crazy, nonstop team chat have in common with the technology that powers Netflix? It sounds like a weird question, right? But the answer is everything. They both revolve around this one single idea that can either cause total chaos or unlock some seriously incredible efficiency. So let's dive in and break it down.
Let me guess, your day is just a constant stream of pings, right? Notifications buzzing, meetings stacked back to back, and that feeling, that pressure to be online like 24/7. Yeah, if you're nodding along, you're not alone. That feeling of being constantly pulled in every direction isn't just in your head, it's the direct result of a world that's been built around real-time, right-now demands.
This whole thing, we can call it the tyranny of now. It's this constant demand for our immediate attention. And if we want to break free from it, we've got to understand the fundamental choice we're making every time we communicate or build something. And it really just comes down to two different ways of doing things.
So, what's the big difference? Honestly, it's super simple. It all boils down to one thing: time. That's it. Synchronous means right now. Everyone has to be there at the same time paying attention. Like a phone call. But asynchronous, that's where things get interesting. It separates sending a message from receiving it. Think about email. You send it, they read it when they're ready. See, the two actions are decoupled.
And that decoupling of time, that's where the magic really happens. The moment you take away that must-be-now requirement, you unlock this whole world of benefits. And what's so cool is that these benefits apply to how we work with people and how we build massive tech systems. Let's see how this plays out.
Okay, so you can see the trade-off pretty clearly here, right? Synchronous is all about that instant feedback, great for a quick brainstorm meeting or a simple request to a server. But when you let go of real time, that's when you get asynchronous, and boom, you unlock flexibility for your team and serious scalability for your tech. The use cases might look totally different, email versus microservices, but the core idea, it's exactly the same.
For us, for people, the benefits are just huge. I mean, think about it. When you're not expected to reply in 5 seconds, you can actually work with people across the globe, no problem. The folks on your team who need a minute to think things through, they can contribute just as well as the person who talks the fastest. You actually get to focus, to do that deep work everyone talks about. And honestly, the quality of the work usually gets way better because no one's rushing.
Now here's the part that's so fascinating. Those exact same human benefits, they have a direct one-to-one parallel in the world of technology. A system that doesn't have to wait for an answer can handle way more requests. That's what we call scalability. If one little piece of the system breaks, the rest can just keep on chugging. That's fault tolerance. It's just more efficient, and you can update different parts of a big application without bringing the whole thing down.
All right, so the theory sounds amazing, but how do you actually do this? How do you make asynchronous communication work for a real team? Because it's not just about getting some new app. It's about changing the whole culture around how you talk to each other.
Well, the recipe for success is actually pretty straightforward. First, you need the right tools. Things that keep a record so you can always go back and see what was said. Think Google Docs, Asana, stuff like that. Second, and this one is absolutely crucial, you have to set clear rules about response times. Just saying, get back to me within 24 hours can take so much pressure off. And finally, because you don't have those face-to-face cues, you have to over-communicate. Be extra clear to make sure everyone's in sync, ironically enough.
Okay, let's switch gears a bit. We've talked about people, now let's talk about code. Because developers have been wrestling with this exact same problem for years. How do you tell a computer to start a task, go do something else while it's waiting, and then come back to the first task when it's finally done?
The whole story of asynchronous code has been a journey towards making it simpler and cleaner. It started way back with something called callbacks. They worked, but they led to this tangled, nested mess that developers literally called callback hell. Not fun. Then we got promises, which was a huge step up, much more structured. But the real game changer, the modern standard, is async/await. It's this beautiful syntax that lets code wait, patiently, without looking like a total mess.
You can see the trend right here. As the patterns evolved, the complexity went down and the readability went way up. Error handling got simpler too. It's no wonder async await is the winner. It takes this incredibly powerful concept, non-blocking code, and makes it feel almost as simple as writing regular top-to-bottom instructions.
All right, so let's zoom out again. We've gone from people to a single piece of code, and now let's look at the big picture. The massive, sprawling systems that run pretty much every app you use. This is where asynchrony isn't just a nice-to-have, it's the absolute foundation of the modern internet.
The key architectural pattern here is something called publish-subscribe. We just call it PubSub. And the idea is it's beautiful. It's so simple. You have one system that publishes a message like, hey, a user just clicked this button, into a central channel. It has no idea who's listening. It doesn't care. Then any other system that's interested can subscribe to that channel and do something with that message. They're totally independent.
Netflix is the classic example of this in action. When you finish watching a show, your device sends out an event. That event gets published into a giant stream. Instantly, all these different services subscribe and react to it. The recommendation engine grabs it to figure out what to show you next. The analytics service logs it for data. The billing service might check on your account status. The key is none of these services need to know about each other. They're completely decoupled, which is incredibly powerful.
But of course, with all this power and flexibility, there's always a catch, right? Going async doesn't magically make all your problems disappear. It just changes them. You have to look for issues in different places, and managing that complexity is the real trick to building systems that don't fall over.
There are definitely some classic traps you've got to watch out for. At the code level, you can accidentally create deadlocks, where different parts of your program get stuck waiting on each other forever, grinding everything to a halt. At the system level, you have something called a poison pill, one single badly formed message that can get stuck and block an entire queue. Or, even worse, you might tell the system a task is done before it's really done, which is a great way to lose data.
So what do you do with those poison pills? How do you stop them from wrecking everything? Well, the standard playbook includes something called a dead letter queue, or DLQ. The idea is simple. If a message fails to get processed, say 3 times in a row, the system automatically shunts it over to the special separate queue. This keeps the main production line moving, and an engineer can come in later and figure out what went wrong with those bad messages without causing a full-blown outage.
And for those times when a service is just temporarily overloaded, the smartest strategy is called exponential backoff. Instead of just hammering a failing service with retries over and over, you get smart about it. You try again after 1 second. Still fails? Okay, wait 2 seconds. Then 4, then 8. You see? You increase the delay exponentially. This gives a struggling system a chance to breathe and recover, and it stops a small hiccup from turning into a massive, cascading failure. So, as we bring this all together, I just want to leave you with one final question to chew on. Take a look at your own work, your team's culture, or maybe the technology you're building. Where is that pressure for real time, for an instant response holding you back? Where is it creating a bottleneck? Because I'm willing to bet that's the exact spot where the power of asynchrony is just waiting to be unleashed.